Hi, everybody. Welcome to this GOOS webinar. We will just give it about 30 seconds more to let a few more people come into the room and we'll start. Okay, so welcome to this Global Ocean Observing System or GOOS webinar. My name is Mairead O'Donovan. I work as a consultant with the Global Ocean Observing System Secretariat, supporting the 3 GOOS Ocean Decade programs. These programs aim to enhance and expand the Global Ocean Observing System to provide greater benefit for society. This webinar will give you an introduction and some insight into one of those programs. So today we're talking about CoastPredict. In the new year, we plan more webinars to feature the other GOOS Ocean Decade programs, and we will be in touch about those. This session will include a 30-minute presentation followed by questions and answers. We invite you to type questions in the Q&A box, and I will read those out during the second half of the webinar. Please be aware that the webinar is being recorded and the presentation slides will be available through the GOOS website, so you will receive a follow-up email to show you where you can find the slide deck. I am very happy now to introduce Nadia Pinardi, who is a professor of oceanography at the University of Bologna in Italy. Nadia is the chair of the CoastPredict program, and she is also the director of the recently established Decade Collaborative Centre for Coastal Resilience, which is hosted by the University of Bologna. Nadia is an expert in design and practical implementation of ocean forecasting observing systems across the world, open ocean and coastal areas. She is presently the Vice President of the World Meteorological Organization's Commission for Observation, Infrastructure and Information Systems. So Nadia, I have the pleasure of meeting you quite often during the CoastPredict program meetings, and it's always a learning experience for me. So I'm looking forward to your presentation, and I hand over to you now, if you're ready, please.
Thank you very much, Mairead. And for me, it's always a pleasure to be in the GOOS community and seeing the new people that can help us to build this very important network and program, let's say, not network. So my co-authors are Willy Curafalou from University of Miami and Joaquin Tintoré from SOCIB in Spain. And, you know, I really have to thank them for all the time that they have dedicated and their knowledge to the setting up, the initial start of this program. We are still at the beginning. So I will go briefly on the UN Decade at GOOS, and I will take a bit more time on the concept of the global coastal ocean that we would like to have consolidated by the end of the decade, and looking at some knowledge and technology gaps, and then trying to show you what we think we should do to overcome the gaps, so what I call the CoastPredict solutions and some outlook. So the decade, as you know, most of you know, is really dedicated to transformative science that will help, that will support sustainable development, connecting people in our ocean. That is, you know, a unique opportunity. Since of my age, I have been in other decades, and I have to say that this is a very special one. It comes after a major innovation in operational oceanography and GOOS and biochemical observations being taken now. And it is really time to have this connection with societal benefits. So we are all very happy about, you know, going into a phase where together with our big GOOS program, we will add the pieces that will make GOOS stronger to support for sustainable development. So CoastPredict is one of the 3 GOOS programs. One is Ocean Observing Co-Design, which will be described, I guess, next year, and Observing Together, focusing on capacity development, on co-design, all very important, and CoastPredict focusing on the coast, having elements of co-design and capacity development. So GOOS has really done magnificent work, and not because CoastPredict was accepted as one of the program, but in trying to streamline and find the gaps that are present now. So going now to the concept of the global coastal ocean. We're still, I mean, even though the 4 volume of the sea that you find here, I don't know if you see my mouse on the bottom right, there are actually 4 volumes of the sea which talk about the global coastal ocean. I don't think that we have actually implemented this new concept, and we are actually now, after 10 years, this concept was first drafted, we are changing it because our knowledge has expanded enormously. And we are expanding it inland. We are expanding it inland, connecting the river basins to the ocean in this fundamental interaction of the knowledge of how the coastal works and how
Nadia, you're on mute for some reason.
So nobody heard what I said?
I heard until just now. Just now your sharing stopped and you went on to mute. So no, I heard up until just this moment.
And now am I sharing still?
No, you're not sharing.
Oh God, something
It just stopped. We haven't missed anything. It just stopped. Okay.
Something strange happened. Let me think. Okay, now I should share again. I apologize. What is the issue here? Yeah, now I know. Start sharing, share. Okay, I hope we're not.
It's coming back up now.
Okay, great. Thank you very much. So the present non-uniform at present we are still in non-uniform terminology: coastal margin, coastal zone, continental shelf, continental margin, and so. And we need to find a uniform definition, because through this definition we will be able to better design the solution to the problem, which really in this transition zone, which should include urban settlements and that connects the coastal ocean to the offshore, to the shelf slope. We know how many systems in the ocean, such as western boundary currents, are fundamental to what happens to the coast. Okay, so we have a big job here to do. The first classification, what I wanted to show you is was done in this book. Now it is volume 14, on the basis of big regions and then physical processes, biogeochemical processes, and the offshore, which are very important concepts. And I think they will be maintained. As I said, we will extend a bit more landwise. Key processes linking land, sea, and atmosphere. That's the point. The coastal ocean includes the coastal zone, the one that traditionally is called the coastal zone, and it extends up to, sorry, let me take this out, yes. It extends up to the shelf and slope. Now we are really also capable to think at this toward this complexity. Okay, so but why do we need the shelf and slope? Most of us work in estuaries and very close near the shore. And here is an example you see of a model that was set up at Georgia Tech by a collaboration, international collaboration, and it was done for getting sea level at the coast of Georgia, and especially when hurricanes are coming. And you know, here is the result of this model nested into a global one, which is a key, another one. And here we have a result that is interesting. That is the total surge is in black, the sea level from offshore, meaning from changes in the Gulf Stream and other signals due to the track of the hurricane when it is still far from the coast. And then local hurricane winds is the red. And you can see that in this area, the offshore is extremely important to get the surge. So we need to have a concept that includes this sea level from offshore, which means extending to the shelf and the slope. So the technology gap is to have an integrated approach. Here is an example of how we have to think models and data, observations and models, and from inland to offshore, they have to, and the concepts and the, let's say, the sampling scheme has to be relocatable. It has to be multi-sensors, smart sensors that are actually even cheap, and then delivering data in real time, as we do now for the open ocean. This is another technology gap which we need to complete. The seamless ocean forecasting. Going seamlessly from the open ocean, which we know the most, to the coastal areas with a modeling framework and an observing framework that can be useful to the Sustainable Development Goals. This is an example for the city of Taranto in the southern Mediterranean Sea, or southern Italy, you may say. But we like to have this happening everywhere. And there is technology and there is knowledge has to be standardized in order to do this. So CoastPredict high-level objectives. First of all is to have predictions for the global coastal ocean, every place along the global coastal ocean. Maybe there will be different degree of achievement depending on the difficulty and also the existing at this time infrastructure, but hoping to bring everything by the end of the decade and especially after the decade to a very good level if we develop well, and then upgrade the fit-for-purpose oceanographic information infrastructure, which is fundamental even more here. You see now that the ocean forecasting at the coast is connected to having the open ocean part. And this is something that will never be changed with even higher resolution offshore models. It just will require always the kind of downscaling and nesting. Then co-design implementation of integrated coastal ocean observing and forecasting system, and with best practices and standards. Designed as a global and implemented locally. The expected outcome is this integrated knowledge of the global coastal ocean, the design implementation of integrated river, estuarine, coastal, open ocean observing and modeling, multidisciplinary system, improved coastal marine forecasting, extended range capabilities for the coastal zone, development of method for trusted data information exchange, innovative and sustainable applications that stem out of the previous outcomes and services that are directly benefiting local populations, and then increase equitable education and capacity, which should start from from all the outcomes. So I like to think that in the ocean we have now a good idea of the value chain. Now we need, and certainly for the open ocean, this is the open ocean value chain now, from the real-time observing to routine ocean monitoring, predicting, on also a new part that is of data analytics and on-demand modeling, which is being constructed now, and then customized applications. But we need to reinforce this value chain for the coast. And in order to do that, we have to try to devise systems that will be operational, even more in the coastal areas than in the ocean, if I might say so. We need to have requirements and feedback going through all these components. Okay, so up to now, mainly, and it was great, it was a major thing, the large-scale ocean observing and predicting system has been set up. And now the challenge is to connect in a rational way and in an efficient way to the coast, with real-time and international standards, a protocol, open and free data as much as possible. And we have some technologies already well developed, like coastal radars and tide gauges, but we could do more. And then we could, for example, and we have also autonomous underwater vehicles already, but we have more to do on maybe drones for the coastal area, citizen science monitoring, and so on. And without talking about the different models that we can use in the coastal area to adapt to the complexity. So we need to develop a lot of new technologies and best practices. And this is what CoastPredict actually would like to do. So one of the major effort is in transforming the observing, including citizen science and or what we call now among ourselves still, hopefully you like it, community science, which here you have an example from smart sea level sensors that helped us to get that good result into the Georgia region here in United States, and then other even more interesting biogeochemical, and this is biology, networks that are flourishing everywhere. Here is a fantastic one on taxa recognition by artificial intelligence methods. And as you can see from the red and the yellow, you know, the automatic recognition is starting to become very efficient. And And the other part that we would like to do is to have these models that you have already seen. And here you see the salt. You see the salt intrusion into the river. We're still missing the underground. We're still missing, all the connection with the aquifers. But hopefully, having this start where at least we drive the salt up the river, we could probably think of doing also the underground water. So then another, and I'm close to the end, another thing that we are thinking to be very useful for societal benefit is to use a digital twin framework methodology to test, for example, nature-based solutions. A lot of our development is concerned with nature-based solutions. So the development in observing and modeling the coastal area. And here we can use models that are now complex enough to represent reality. And this is the digital twin modeling. And we can answer questions like local seagrass, are they capable to decrease wave energy? And do what-if scenarios. And here is the example, for example, that we did for my coastal area, the Emilia-Romagna coastal area here, with these highly resolved unstructured grid models, where we can put models of seagrass, and this is a particular one that is endemic of our region, which is the Zostera marina, and then show that under certain various circumstances, there is a dramatic decrease in wave amplitude. And so, okay. CoastPredict, in order to do all this, subdivided the work among 6 groups, 6 what we call focus area. One is for the short-term coastal forecasting and early warning. The second is for the climate downscaling, coastal climate monitoring and downscaling. The third is for integrated coastal management based upon data coming from all the 6 areas. And then coastal ocean and human health, which is a bit less developed than the others, but we hope with some of you who are even listening now, we will be able to expand that. That's very important. And then the cross-cutting one, which is the international open and free access information system that we need to build out of the coastal information with the new technology. And then the focus area, which also is a cross-cutting part. We thought of working with core projects in these areas and keep a continuous running of ideas across the areas. So we have now at this point one core project with an implementation plan which is called Predict on Time, which will develop a system to observe and predict natural extreme events in the global coastal ocean. There are affiliated projects for this, which we are starting to get in touch with, in particular one in the Argentinian Sea, and the other on the tropical Americas and the Caribbean. The focus area 2 has also a core project. It's called FLAME, Future Coastal Ocean Climates, which also has an activity which is a European at the moment, but hopefully expand to the global on knowledge hub on sea level rise. Focus area 3 has a nature-based solution project funded through the UN decade, talking about mangroves in Ghana. And then we have a core project for international open and free access to coastal information. There is a call open for projects to be affiliated to CoastPredict. And if you have any idea and if you would like to check with us, please contact us. But please bring us your idea out, they will help to meet the challenges of CoastPredict. So we are developing, as we have said, the coastal ocean concept. We are starting to define it. We are starting to see coastal solutions being emerging, implemented, or soon to be implemented. And we need to use this in an extremely multidisciplinary approach. So we plan to do this implementation in several world ocean test areas where we have the real trial of the system, the new system, and the many systems that can be applied in order to find the standard, the international standard. So get involved. CoastPredict hopefully will make a lasting change, which we need for the ocean, and get in touch with us. Myred, myself, anybody, you can find it on the webpage. And thank you for the attention.
Thanks very much, Nadia. Really interesting to see how the CoastPredict program has been developing. There's wonderful insight. I don't see any questions so far in the Q&A. I did put an answer into one of the questions about the getting more information, and it's here also. So CoastPredict has a really nicely developed webpage, and I encourage you to go onto it, coastpredict.org, to get more information, and there's a contact form there also to get in touch. So while I'm waiting, if you have any questions for Nadia about the presentation or about more detail, please put them in the Q&A. I see a question just after coming in from Laurent. For topic 4, so for focus area 4, do you have any projects yet under focus area 4, Nadia?
No, thank you for asking. No, we need projects there. It's actually something that hasn't been developed much in the first 2 years, because we had more mature parts like focus area 1 and 2 and 3, I would say. So we're really looking forward from proposals from your side to start that part. That's a crucial part. It involves a collection of observations on human health that are crucial to our future, and putting them together with adequate biophysical and biological observations in the coastal ocean. So really hope that part will get through. Yeah, and you can actually submit now. So there is a call open for submission of these projects. As I said, I'm available to help if needed. I mean, sometimes is absolutely not needed. And call for project, it will end 31st of January.
Okay. Thanks, Nadia. Just to note for people, I've noticed that some people have their hands raised. Because we're in webinar format, we'll ask you just to type the questions in the Q&A box, and we'll come through to them in order, please. So there's a question from Uma Sankar. Nadia, can you highlight on best practice and standard protocol for integrated coastal ocean forecast systems? I don't know if this refers to how this will be highlighted through the program. I know that there's a focus area, Nadia.
Yeah, but it is a very important point, and it is being started in the elaboration by the group, the core project. But if you ask my opinion, this is an area which is really of great importance, and we have at the level of the UN Decade, in addition to the Decade Collaborative Center for Coastal Resilience that looks at the product for societal benefit out of CoastPredict and more, there is another DCC, which is DCC on ocean prediction, which is of fundamental importance. And the best practices will involve to have access in accessible, access in inaccessible, in a suitable, fit for purpose way to larger scale information, which ocean prediction will coordinate, and then have the additional data from the coastal area and the models of the coastal area fitting adequately, being efficient to bring that information to the coast. So it's really fundamental. Up to now, we didn't have this. We have an experiment in Europe, as you know, a service, not an experiment, a service in Europe that started to do that, but accessibility with standards that are not very technical is still an issue. We need to look at increasing the number of users. And this is true also for, let's say, satellite data and even for GLOS data, tide gauges. So we have the problem of the information, the ocean information system containing the coast. It's a real primary one. I don't know if I've answered the question.
Okay, thanks, Nadia. Umasankar, you can add a note in the Q&A if there was another theme to that question that you want to cover. So one of the questions, Nadia, from Dr. Ibrahim Zia is, what is the criteria for a core project?
Very good question. So the criteria would be to be as close as possible to what in the programs we outlined that are the in the implementation strategy, that are the main point of the implementation strategy. So there are some key issues that is, sorry, this is the, yes, a project should be formulated, and this is the part, but you shouldn't be afraid. I mean, it could become even, you know, if you submit a project which is lacking something to become a core, it's not a big problem. We can make it a core by adding the missing part, but projects should be formulated following some basic principles. And so the ones that are now are the closest to include all these principles. So have a clear stakeholder engagement plan, some very different areas of implementation with relocatable solution include, I don't know if you can see my screen, Morad? I guess so.
We can, yes, yeah. We're looking at the website.
Provide end-to-end demonstrations, multinational, multidisciplinary. I mean, it's not very different what you would think to do for a project. Make an effort to use new methodologies and technologies with different aspects of the project. Include a plan for after the project continued development. Because we want to leave a sign, and we want a legacy, especially to GOOS. So this is operational oceanography, I guess you have, and I think it's is a part of the transformed science that is closest to the applications. Okay, there is still a lot to be known about the ocean. There's still a lot. The ocean is not very well understood yet in many parts, the deep ocean, the Arctic, the Antarctic Ocean, everything, you know, I'm just making a few examples. And but here we have to arrive at almost close to solutions. We have to give data and data model and observations, or actually first observations and models that are useful for applications. And this is what operational oceanography is practically. So to conclude, I think that we want to try to be transforming, you know, in the way that will at the end leave the legacy of a coastal operational oceanography service, which now, in my opinion, even though we have many attempts, we know Met Offices uses from long time, you know, an approach and so on. But I think that, as I said, is an approach that looks at the ocean separately from the land, and so which should be ameliorated. Thank you.
Okay, thank you, Nadia. There is a question from Johnny Johansson. There is a big and broad range of demand for in situ observing systems for processes understanding and model validation. Can you comment on how to tackle this?
Yeah, thank you. Again, a very good question. We believe that even more to the coast, you need to have a scheme and a method to calibrate and validate models, and that is also time dependent. I mean, this calibration and validation should be repeated. We know bathymetry changes. We know river runoff changes dramatically, loading, coastal ecosystems change. So, and urbanization change. So we need to have, we are thinking how to set up a system that not only corrects the models, but really calibrates and validates the model. This is really the crossing of engineering with science. You know, my experience is that we should learn a lot from what it was done in engineering and add the parts that is missing, and, you know, do this calibration and validation really full, you know, and understand the process. If something that the calibration requires is looking at the specific process, because it's not like the bottom drag, for example, is not well parameterized, then let's do a process-oriented experiment. But this is exactly the point of integration between observing and modeling, which I think will give us the new capacity.
Okay, great. Perhaps following on the topic of integration, there's a question about possible synergy with tsunami, meteo-tsunami early warning and mitigation systems and efforts, both from the instrumental observations and coastal community disaster risk resilience point of view. So do you see possibility for synergy with those elements, Nadia?
Yes, I mean, we have been actually suggested to get in touch with the program, which is on tsunami early warnings, monitoring, and so on. And clearly, we need to. It is efficient. It is important because one big tsunami is 100 storm surges, and so what we really need to is, we need to get together and think about how to get cheaper technology, which normally we use in the coastal area, to support the tsunami, which is it's more expensive, has higher frequency of data collection, requires is a more data intensive initiative, and even for the model get together. This part I think will start next year, hopefully. Hasn't been mentioned yet because it's something that we wanted first to have the program from a tsunami, from the tsunami program. We wanted to have a UN decade tsunami program well set, and so we can start talking together. And I guess now there is a UN decade tsunami program that has been endorsed.
Okay, thank you. Yeah, it's exciting, the number of initiatives and programs that are happening as part of the decade. And I think one of the next steps and part of the process for everybody is to see how we integrate across and find synergies between different programs and efforts. Nadia, there are a few questions sort of specifically about themes under the core projects and focus areas. So I'll kind of group these. There's a question about what has been done so far in terms of harmful algal blooms, and if this is a theme that will be covered under CoastPredict.
Well, as you know, and as we all know, there is already a very well-formed group on harmful algal bloom by IOC in Copenhagen and more. So we plan to get in touch with them and start a discussion with them, building on their knowledge, which is very extensive. I mean, this is IOC is a leader in harmful algal bloom expert teams, and what we like to do is think that our new technology will be of help to early warning for algal blooms, and so we have to start that connection, and hopefully next year it will be the right moment, since we have arrived to a certain number of implementing projects. Some of them talk about harmful algal blooms, such as Predict on Time, but without developing the very important part of the biogeochemistry and biology, because we think that that could be taken from the hub group of IOC.
Okay, perfect. And I suppose following on from that, there's another question about considering fauna, and I think avian fauna specifically under core projects. So I expect a similar, the situation is similar for that, in that we need to connect with the groups that are doing that across programs.
Yeah, I think, sorry, I didn't understand which kind of fauna.
Avian fauna is what I...
Right, yeah. I guess this also is a part that we need to scrutinize the programs and get in touch with them and find the right connection to strengthen that feedback. We hope to be able to sort of do something innovative ourselves, not ourselves, I would say this group up to biogeochemistry, and then after that get in touch with the other new programs that are looking more to fauna.
Okay. moving on to another question from Martin Saraceno. Will there be support for observations specifically to buy and deploy instruments for real-time monitoring in coastal areas?
That's the 100 million, probably billion question. Now that we have the program in place, we are eager to start to campaign for funding. And so that is our aim. And is actually the aim also of the Decade Collaborative Center to help on that search by also putting together different programs. So the answer simply is yes, but I cannot tell you now exactly what and how. So the Decade offers opportunities which we haven't explored yet because we were busy in trying to be systematic and having a systematic scientific approach. But now, next year, it should be the year that we focus on the funding. And we really would like to get private and public funding for this. I think that if we do it well, if we explain well the aim, I think that we will find, and the aim is to buy new instrumentation, is to have new computers for running bigger models, if you want. That's a bit more difficult, but at least think that you can have enormous capabilities from the point of view of computing resources. And without talking about AI, which also is pervasive in many of the focus areas to be explored. For example, I would say human and ocean health will have a lot of that AI.
Okay, thanks, Andy. And I think, am I right in saying that the approach of working through pilot areas will be a way to do an initial set of observations and deployments in certain areas? Yeah,
exactly. Yeah, we did the focus areas in order to restrict a bit, because otherwise it looks like huge. Yes, so the focus areas are done to a bit to come to focus in a specific one, and they're both all areas, not both, all areas are asking for new sensor, new instrument, new methodologies, and so on.
Okay. There is just a reminder, I have put the CoastPredict, it's on the screen here as well, the CoastPredict website, and it's a really well developed website. There's a lot of really good information, and I think, Nadia, there's going to be more detail being put online about the various focus areas and pilot study regions as that becomes available. So I would encourage people to look at that and to keep an eye on that, because I think it's a really useful resource for information, and then also even for names of different people and institutions who are involved. So just recommend taking a look at that. Still a couple of more unanswered questions. There's a question about, so it says, you've stressed the need to set up an integrated data collection system in coastal zones. However, some coastal countries either do not have the means or do not want to share their data, sometimes related to issues related to poor knowledge of the issues. And some of these countries are members of UNESCO. How do you think you'll solve this problem? Or is there, is there a provision in CoastPredict to work with these communities and countries to get access to that sort of data?
Well, we are definitely open to include all countries that want to advance their science, their understanding, and their knowledge about what technologies are available, which technologies are available. So we are definitely open, and no restriction of any sort. Yeah, I come from an old motto that was science for peace, and I'm still for that completely. And I still think it's true. Science can make peace. Now, we have many sectors in oceanography which are under the problem of countries not yet sharing their data. But there is a point in which when there is something that I see happening. It happened for IODE, it happened for operational oceanography, that at a certain point there is a limit, and that when the people start to recognize, I guess the audience, or the person in the audience asked, said that there is a moment in which the benefit of getting the other data is so large, and being excluded from planning the next phase is so it's so large. When you get a bad, then it will change. But we can't really do something directly, right? Oh, the other part is very important, is that we have GOOS in the member assembly. So the UNESCO IOC member assembly. And it is also through that, it is our relationship with the policymakers that we have to, and this is why we did the UN Decade program, because we believe that if we accomplish our aims as scientists and we bring this to the IOC assembly, the member states will start to see new avenues, new solutions for their problems. And from there, you will change. You know how important is now the connection with policymakers. And in our case, the assembly is a very important, the UNESCO IOC assembly is a very important point. So, yeah, I guess we are open to everybody, absolutely, sharing to everybody completely as much as possible, and then as much as possible, meaning in terms of capability and time, but this is a wave that will bring people together, as it has happened for the Met offices. Still, also in the Met offices, we have countries that don't contribute as much as others, but with the time, things change, and actually they always grow. They always get positive increase in number of observations and models and information shared.
Okay, I think this, what you've just discussed kind of links with another question. And, we talk quite often about highlighting the benefit to society and the value for people and for communities. And one of the questions here is there an opportunity for quantification of ecosystem services from coastal ecosystems in any of the core areas? So is that specifically a theme of any of the core areas, or is it covered across a number of them?
Yeah, it is covered across a number of focus areas, because ecosystem services go across time scales, space scales, and so. And I think this is a very important topic that we have written it as word in the program, but it's not yet let's say a main project or anything. And it will be nice to have it added. I think there is the framework for this to be added between the program and the core projects and the affiliated project, and it will be very valuable. It will be a great contribution to CoastPredict. Sorry,
okay,
I didn't finish. I mean, is there some, some other, maybe your question was also how to contribute, and not only as ecosystem services, but also, or mapping the ecosystem services. But maybe you were asking how we're going to really arrive at the societal benefit. Well, we are mostly scientists, but also social scientists working, so let's say hard, so to speaking, scientists and social scientists working in CoastPredict. We have economists working with us, and the society. So we are definitely going to prepare the best data for policymakers to take a decision. And so I think that, or hopefully we will. So I think that that is our aim. That's our job. The other part that's very important is the co-design part. So we plan to do this in our test areas, to do it with an ample co-design participation by the local community. How to do that, I don't know yet. We have the scientists, the social scientists working with us. They're thinking how to do this, and there are several already experience around the world. We will take the best and adapt it to the new science.
Okay, we have just a couple of minutes left, but I think related to this point, there's, I suppose, a comment rather than a question here, which I think is quite relevant. The effort is very important for the US Coast Guard search and rescue. They employ surface currents and wind forecasts for drift modeling to search for persons and crafts lost at sea. So accurate surface currents and winds are essential for successful outcomes. And there are certain coastal areas where they do not have enough resolution. So hopefully this program can facilitate the development and implementation of higher resolution models in coastal areas, which will render greater accurate predictions. So I think that kind of is a nice example of that benefit to people and society.
That's right. Yeah, this is a very, let me say this because I actually started many years ago to work with the Italian Coast Guards. And in addition to finding very interesting, the kind of problems and this, let's say, the science that you can learn by solving this problem, Lagrangian trajectories and probabilities of different kind of bodies in the water, which is, typically a scientist issue. I wanted to say that one of the major issues at the moment, I think, is that data, and this is the part of data availability, accessibility. We are not at the level where our high resolution models can be accessed in an easy way, as much as they are from a Met Office or, from, for example, the open ocean, which has a coarser resolution. So I think that here we have to work a lot on best practices in making these high resolution models available to society. And thank you for reminding us about this important this important usage of our model, which we take it for granted, but is not. So, I mean, serving the Coast Guards and the search and rescue activities is very fundamental. And so, hopefully, if we develop these models in these test areas and we know how to transmit them in order to be comprehensive, but at the same time feasible, I think we will get a maximum benefit for the Coast Guard activities.
Thanks, Nadia. And I think that's a nice and a positive note to finish the webinar on. There's a lot to do. And it's an exciting time. So thank you so much, Nadia, for presenting and for answering these questions. We're at the top of the hour. Thanks everybody for joining. We encourage you to participate in more of these GOOS webinars. You can join the GOOS mailing list if you're not already on it, and we send notifications there of what's coming up. So many thanks and enjoy the rest of your day. Thank you. Thanks, Nadia.